Okay, we are back. We're looking at 3.7, derivative of inverse functions. Page 24 of the note packet, we are going to skip that. That is not very urgent. And on page 25, we'll go through some problems here. But again, you don't have to memorize these. All right, so we have d dx of the arc sine of u, which is equal to u prime over the square root of 1 minus u squared. We've got d dx of the arc cosine of u, which is equal to the opposite of u prime over the square root of 1 minus u squared. We have d dx of the arctangent of u, which is equal to u prime over 1 plus u squared. Wow, these markers have like a half-life of 2 lectures. Try yet another marker. Okay. d dx of, where was I? Arc cotangent of u is equal to the opposite of u prime over 1 plus u squared. d dx of the arc secant of u is equal to u prime over the absolute value of u times the square root of u squared minus 1. And the last one, d dx of the arc cosecant of u is equal to the opposite of u prime over the absolute value of u times the square root of u squared minus 1. So don't memorize those. I mean, you can write them down, and then let's see what these look like in action here. So we'll do a couple of problems on. This is page 25 of the note packet. We're Calc 1, Chapter 3, Section 7. So we will refer back to these. So you should have written those down on the top of the page. And here goes. Let's take a look. We have find d dx of the arc sine of 5x. So we're going to say u is equal to 5x, u prime is equal to 5. And then for sine, it's just u prime, which is this, so 5 over the square root of 1 minus, and then 5x quantity squared. And that's it. So number 2. d dx of the arc tangent of the square root of x. And so we're going to say that x is equal to, or I'm sorry, not x. Ay caramba. U is equal to x to the 1/2. U prime then is equal to 1/2 x to the negative 1/2, which is equivalent to 1 over 2 square roots of x. And so then what do we have for the arc tangent? If you look up at the arc tangent, it says it's u prime. So 1 over 2 square roots of x over 1 plus u squared. So this squared. So the square root of x squared, which is just going to be x. So what does that end up being? Well, remember how this works. We have 1 over 2 square roots of x divided by 1 plus x over 1. And so we never divide fractions. We multiply by the reciprocal. So 1 over 1 plus x. And that's where the show stops. 1 over 2 square roots of x times 1 plus x. All right. So that is 1 and 2. It's in Roman numerals, so you know. Let's look at 3 and 4 and 5. So number 3. Is y is equal to 25 arc sine of x over 5 minus x square roots of 25 minus x squared. Okay. So we got y is equal to 25 arc sine of 1/5 x minus x times 25 minus x squared to the 1/2 power. And this one, we'll do the u substitution, 1/5 x, and u prime is 1/5. And this one, we're going to have to do like the first and second, the product rule. So we've got a minus, and remember how that works. That is first times derivative of second plus second times derivative of the first. So first x times the derivative of that, which is actually going to be, right, a little more complicated because we've got we got to pull the 1/2 down. So this is times 1/2 times this, 25 minus x squared to the negative 1/2 power. So we just did that, pulled it down in front, did, you know, take 1 away from it, and then multiply by the derivative inside there, which is negative 2x. All right. And then plus the second, which is this thing. Times the derivative of the first, which is negative x, so that's negative 1. All right. And so how do we end up with what we end up with? Let's take a look. So we have, let's see, this part of it is y prime. So when you look back at sine, it's y prime, which is 1/5, that's on the top, over the square root of 1 minus x over 5 squared. So we got that. And then minus, let's see, we have negative 2x times that. That is negative 2x squared times 1 over 2 square roots of 25 minus x squared. Now, don't even think for a second to distribute a square root over a plus or minus. You can't. So that just stays the square root of 25 minus x squared. And then a negative times, that is going to be minus the, there's another parenthesis there. We can't distribute that, so we're just going to put the negative in front of it, and then 25 is x squared to the 1/2 power. All right. And then we should really take that x times that. All right, so we did this times that, got it. That right there, got it. And now the negative distributes to both of those. So we end up with 1/5 divided by this, which is going to be multiplied by the reciprocal, right? So 1/5 divided by the square root of 1 minus x squared over 25 over 1. And then plus 2x squared over 2 square roots of 25 minus x squared, and then plus 2x squared times the square root of 25 minus x squared. And so then the last thing here we have multiply by the reciprocal, so 1/5 square roots of 1 minus x squared over 25 plus those 2's will cancel, x squared over the square root of 25 minus x squared plus 2x squared square roots of 25 minus x squared. Ugh, what a mess. So let me see, is that what I have down on my paper? 1/5. I got that. I got that. 25. Oh, that 2x isn't going on there. Wait. The 2x is only on the first term. So not there. There should have been an end parenthesis there. I should have end parenthesis that. I put that up there, and then it's not attached to there. So I have an extra 2x squared there. That shouldn't be there. Just that. But that should do it. There we are. So, yay. What a mess, huh? So that is the derivative of that one. And I have to fix this as 1/5. What a mess. Okay. And that was a negative, and that was a so that should be a positive. Alrighty dighty, so on to the next one. Which is the last one on this section. So find an equation of the tangent line to the graph of y equals arc secant of 4x at this point, the square root of 2 over 4, comma, pi over 4. Okay, so again, we've kind of done this problem before. Where we've got, first let's find y prime. So arc secant of 4x. So y equals the arc secant of 4x. So y prime for secant, we got u is 4x. And u prime is 4. And so for arc secant, that is u prime, which is 4, over the absolute value of 4x times the square root of 4x quantity squared minus 1. And so when we do f prime of the square root of 2 over 4 for this, what we're going to do is we're going to put that in everywhere where we see an x. So you've got 4 over the absolute value of 4 square root of 2 over 4 times the square root of 4 times the square root of 2 over 4 squared, and then minus 1. So the upside of all these 4s are, we're going to get some, we can just cancel those, we can cancel that. And so we have f prime of the square root of 2 over 4 is equal to 4 over the absolute value of the square root of 2, but the square root of 2 is positive, so we don't have to worry about the absolute value part. And then the square root of the square root of 2 squared is just 2 minus 1. So that is square root of 2 over 4, which is 4 over the square root of 2, right? Because this is really just the square root of 1. Square root of 1 is 1. 1 times anything is just the square root of 2. So if we want we shouldn't leave it like that though. We shouldn't leave a square root in the bottom. So we will rationalize the denominator by multiplying top and bottom by the square root of 2, and then that's going to give us 4 square roots of 2 over 2, and then the 2 is going to go into the 4 twice, so 2 square roots of 2. So that is the slope. So we've got the slope. So again, we did this before. We're y minus y1 equals slope times x minus x1. We've got the slope. And we've got our point given the square root of 2 over 4, comma, pi over 4. And so now we're just going to plug and chug, substitute and simplify. Pi over 4 there, 2 square roots of 2 there, square root of 2 over 4 there. Oops, wait, we got to do x minus that. So 2 square roots of 2x minus, I multiply those, right? I get 2 square roots of 4 over 4. And then I'm adding pi over 4 to that. So let's not reduce that down to 1 because I want to write this all as one thing. So let's fix this. This is just 2 times 2. So let's leave it 2 square roots of 2x minus 4 over 4 plus pi over 4. And then we can say y equals 2 square roots of 2x minus 4 plus pi all over 4. Isn't that lovely? Alrighty doity. Oh, wait. But that negative was only on the 4. There we go. Because this is positive. So the negative's only on the 4. So make that a plus and not a minus. Or if you want to make it a little neater, we could call it pi minus 4 over 4. There we go. Lovely dovely. That is the equation of the tangent line to the graph, the arc secant of 4x at the square root of 2 over 4, comma, pi over 4. All right, that is it for 3.7.